Every model in this series so far stood completely alone. This episode breaks that. What if you trained several mediocre models instead? Individually, each one is unstable, a little wrong, easy to beat. Combine them the right way, and something strange happens. The group becomes measurably stronger than any single model in it. This is episode 13, Ensemble Learning, Bagging, Boosting, and Stacking. By the end, you'll build an ensemble that beats every model inside it. Here's the core idea behind every ensemble method. A single model makes one set of mistakes consistently every time. Different models, trained differently, tend to make different mistakes. Average enough different mistakes together, and they start to cancel out. That cancellation is the entire reason ensembles work at all. First technique: bagging, short for Bootstrap aggregating. Take random samples of your training data with replacement many times over. Train one model per sample, same algorithm, slightly different data each time. Average their predictions or let them vote and you get bagging. Random forest is just bagging applied specifically to decision trees. Boosting takes a completely different approach. Models trained in sequence. Each new model focuses specifically on what the previous one got wrong. Misclassified examples get more weight, forcing the next model to pay attention. Stack enough of these correction rounds together, and errors shrink fast. Powerful, but it can overfit if you let it run for too long. Stacking asks a smarter question than bagging or boosting do. Instead of averaging blindly, train a metamodel on top of the base models. That metamodel learns which base model to trust, and in which situations. It's an ensemble that has learned how to manage its own team. The simplest way to combine models: a voting classifier. Hard voting. Each model casts one vote, majority class wins. Soft voting. Average the predicted probabilities instead, then pick the highest. Soft voting usually edges out hard voting. It uses more information per model. Here's the real difference between bagging and boosting. Bagging mainly fights variance. It calms down models that overreact to noise. Boosting mainly fights bias. It strengthens models that are too simple to begin with. Same broad idea: combine models, solving two genuinely different problems. In scikit-learn, this is VotingClassifier and StackingClassifier. Pass in a list of named base models any classifiers you like. Set voting equals soft, or add a final underscore estimator for stacking. Same pattern as always after that. .fit, .predict. Real demo: a noisy dataset, 3 genuinely different base models. Logistic regression, 71.2%. Decision tree, 68.8. The best individual model, k-nearest neighbors, reaches 73.3%. Soft voting across all three, 75.4%. Already ahead. Stacking with a logistic regression metamodel, 78.3%. 5 points higher than the best model in the ensemble on its own. So which one do you actually reach for? High variance, overfitting model? Bagging, random forest is the default. High bias, underfitting model? Boosting, squeeze out the remaining error. Different model types entirely and enough data to spare? Stacking. Short on time, want a quick lift? A simple soft voting classifier. Let's lock in what we covered. Bagging, resample the data, train in parallel, average the votes. Boosting, train in sequence, each model fixing the last one's mistakes. Stacking, a metamodel that learns which base model to trust. Voting, the simplest combination, hard votes or soft probabilities. If watching that ensemble beat every base model clicked for you, subscribe. Quick look at where we are in the series. We've now covered KNN, naive Bayes, and combining models into ensembles. Episode 14 goes deeper into one specific ensemble: gradient boosting and XGBoost. The algorithm that wins more Kaggle competitions than almost anything else. Episode 14, Gradient Boosting and XGBoost Explained. Boosting taken to its most competition-winning extreme. XGBoost versus Random Forest, head-to-head. Subscribe to catch it. Your challenge task for this episode: train 3 different base classifiers on the same dataset. Task 1. Combine them with a voting classifier using soft voting. Task 2.
Combine them again with a stacking classifier instead.
Bonus. Does either ensemble actually beat every individual base model?
Try it yourself first. The full solution is in the repo.
Post your 5 accuracies and which base model surprised you in the comments.
3 mediocre models. 1 meta model. A 5-point jump in accuracy.
That's ensemble learning strength built out of individual weakness.
Episode 14, Gradient Boosting and XGBoost Explained, drops next. Subscribe. Comment with your own voting versus stacking numbers.
I'm Majas. This is CodeToAGI. Let's build.